Good morning, good afternoon, good evening, good dawn, good whatever, wherever you find yourself on the continent. This is the IoT show, and I am yours truly, Samuel Adjani. In today's episode, we're going to go off tangent a bit. Last week, we talked about connecting our Raspberry Pi to Azure IoT hubs, which we saw. I was going to connect the Azure Sphere to it today, but something happened within the week that I think it just makes sense for me to demystify it on the show. So when we come back, I'm going to show you this. Stay tuned. Awesome, we are back. So to actually put this in context, so that we understand what I'm going to talk about, let's quickly watch this video, and then when we are done, I will explain. Okay, so moment of truth, come to test it. So that is what I'm going to be talking about today. So this has actually, been the talk of on my social media pages for, for the past couple of few hours. It's gone over 4 point something thousand views. Awesome. So I just like, you know what? Last minute, I need to change this and talk about this and how I'm building because it looks like I'm receiving a lot of, positivity out of it. So first, let me clarify a few things. Some people called me and said, why is it that it looked like it took a long time for the water to come? No, it actually didn't take a long time for the water to come. Two things are happening. It's because of the way I shot the video. It was angled at a point that you could not see the soap dispenser. So if you look closely, I was actually taking soap from the soap dispenser and then coming to the water side, to get the water coming from the dispenser. So that is what. So to actually give you a good view, I'm going to flip to another video and then you see that. So that is the soap, and then that is water. So pretty much I've got all the wiring done. It looks a bit messy, but I've got the wiring done. Um, I'm just gonna close it up, connect the pipes. Just gonna connect the pipes, close it up, and then I will do the reinforcement for the front side. Okay, so as you can see from that particular video, you can see that it actually had two sections, the one for the soap and then the one for, the water. Now, why this? As you all know, in the view in this time of COVID-19 where we are all advised to wash our hands, sanitize and all that, this is what happened. So actually, my wife came to me and said, Sam, I need you to take the regular Veronica buckets that everyone is buying and automate it. So I'm going to share a picture right now. So this is actually what she asked for. So she was simple. It was like, take this Veronica bucket as people have it, and then automate it for me. And then I ended up giving her what was on the right. Now let me explain the genesis of this whole thing. When she brought the bucket, if you look onto the right, you see the bucket laying there somewhere. Now when she brought the bucket, we didn't have a pipe. So I had to go find a pipe to fit it. Now, initially, and I would share, where is that model? Yeah, and I will share that with you because today I'm technically devoting my whole show to this build. So let me know if you have any questions. I'll try to answer them on the show. So
This is what I planned to do. The idea was to take the same bucket and then use one of these. Let me quickly flip so you can see this. Um, so you could use one of these motors. All right, you could use one of the this servo motors. All right, this one right here. So that was the plan. So the idea was to pick this servo motor and connect it on the bucket in such a way that I can have it either on the bucket or the pipe in such a way that when I put a sensor there, either an ultrasonic or a proximity sensor on the bucket somewhere or close to the pipe, you would be able to it would be able to turn the taps. Now, the problem I was having was that when I went out to the plumbers to go get the pipe, I wasn't getting any. I was told they'd all been bought, or I had to go with the pre-existing buckets which already had the pipes. Now, I started having a problem because all the existing ones I was seeing would mean that I have to mount this on the bucket. It was just, not cutting it for me. And yes, in as much as you say that if I did it the way you see on the bucket, then we let gravity do its work. Then gravity is going to pull the water down through the pipe, and all I need to worry about is just a 5 volt, servo motor or something triggering it. Now, that's true. That's fine. However, I wanted to take it a step further. I didn't want to obviously touch the soap. Now, a common thing when you go to houses or places right now is there's a soap. I mean, you either have to tap it and put the soap in your hand, which I didn't want to. So the idea was, okay, how do I transfer this idea into something that can be self-sustaining, self-powered, and then hey, it can be cool to have as a project at home, at the office place, at work, restaurant, wherever you want to, something mobile that I can move from place to place. So at the end, this is what we got. This is what I came up with after 5 days of build. I'm, running to looking for pipes, joints, and because the prototype and nothing was planned, all the errors I made, all the mistakes I made, until finally when I was testing it, then I discovered something. So today on the show, I'm going to be demystify how I built it. So if you have any questions, just make sure you let me know, and I'll try as much as possible to answer them. So, first of all, let's go to the. I'm going to show you two things. I'm going to show you the code, and then I'll show you the schematics. So let me open my fritzing here. We're actually going to go back to my page. So let's open the fritzing so I can show you the code and walk you through the code. And one thing I'll do is that I'm working on the final pieces of it. When I'm done, I'm actually going to make this open source. So I'm going to throw this whole code onto GitHub, my repo, and you people who want to replicate the same thing can go replicate it and have fun and do all the crazy stuff. So yes, as you saw, currently I'm using an Arduino. Forget about the motors you are seeing there because I couldn't get the pump that reflected the pumps I was using. Yes, I am using a pump. It is a pump that is able to pull the water from the water source into that whole rig. The thing is that the idea I have is that I could use this in areas where, anywhere, just about any water, any clean water source, you can dump it into it. And the question will be, Sam, what about, can you make it modular in such a way that we don't need a pump? Yes, that's doable. It's just a matter of adjusting the height or using a bucket, and this same contraption can be used. But this is what I worked on. I'm sure there are 1,001 things you can do to make it useful. But let's look at this right here. So currently, this is how it's set up. I'm using an Arduino Uno. There's a buzzer in there, so you hear a beep when it starts, and then a double beep when it stops. I'm using RGB LED, and it turns green when it's ready to use, and it's red when it's in use. And then these two pumps, one represents the pump for the water, which actually is a mini diaphragm pump, and then the second one is just a regular DC pump. Two of them. Then currently in the rig, I am using this IR proximity sensor, this infrared proximity sensor, and I'll tell you what I found about it. The problem I found about it that is making me to remodify the prototype. So the two of them, one is for the soap dispenser and one is for the water. Then here, I mean, obviously, you've been doing IoT for a while now. You know that when you're connecting LEDs, you need a resistor just to reduce the amount of current going through. Now, the new things you're seeing here, these two, this is a MOSFET. I'm using the NPN MOSFET. Now this is acting like a relay. Ideally, I could have used just a sec. I think I dropped one right here. So I could have used this, which is a two-channel relay to turn the pumps on and off. Now, why am I using a relay? This is the reason why I'm using a relay. I'm using a relay because these pumps are external and they are driven off of 12 volts. Now, Arduino cannot give me 12 volts for these two batteries. It would drain or kill the Arduino. So they are using an external power source. And to trigger that, we need either a relay or some mechanism that turns them on and off when you want to. Now, I didn't want to do this because with the initial build, I was going to put it on a bucket. And I felt that, this will just be too much in the bucket. So I went with the MOSFET. So the MOSFET allows me to, it acts just like a relay. So it goes, it triggers when I apply, a high current and then goes off when I apply a low current. And then it's able to turn on power. So that's why I went with a MOSFET. So this is how the sketch looks like. This is how the sketch looks like. Welcome guys, welcome. Let's welcome our guest. Let me know if you have any questions, and I'll try as much as possible to answer them. All right. So this is the schematic. This is how it looks like. And again, I mentioned that I'm going to make this available on my GitHub repo so you can go look at it and build your own. It's quite easy. So what I'm doing now is I'm providing an external power source, 12 volts, and then I haven't actually shown this, but ideally I would show it in a real build. There's actually how do you call it, a buck converter that is actually stabilizing my power to clean 12 volt to the whole system. So the 12 volt is what's powering the two motors, but everything else is being powered by the Arduino, but they share a common ground just to close the circuit. So that's it. Now the next thing, let's go to the code itself. Yep, let me open the code and let me show you what's happening in the code. And then once we are done with the code, I'm going to walk you through the issues I found with this, how I plan to rectify them, and what I'm going to be doing next. So, and I must say, hey, shout out to Ishmael Lamptey. Ishmael Lamte, thanks so much. He came around a few times, was here to film the whole process. So please watch out for a proper time lapse of what we did. And then also he came out, he gave me some suggestions and ideas that went into the final build. So Ishmael Lamte, big ups, thank you for the love and thank you for showing up and helping build this project. So this is not the code we're looking for. Let's go up and read. So pump sketch, there you go. Let me zoom this in a bit. All right. So let's talk through the code. Quite, let's go through it and see it. Yeah, very simple, nothing complicated. Um, and then I'll talk about the modifications I want to do and what I want to see in it. Now, first of all, as always, we're defining all our pins. So I have the water IR sensor, which is on pin 2, the soap IR sensor on pin 7. Numbers doesn't really matter, but once it's on one of the digital pins, you're fine. Then the water pump control is on pin 3 and the soap pump control is on pin 5. Then I add a buzzer for, physical or, notification. And then we have, now the way the RGB LED is that you have to provide 3 pins for all the colors. It's like all the, individual LEDs put together. So red is on pin 8, green is on pin 9, and then blue is on pin 10. And then I define some parameters. Now, this is where I'm defining how long should the water be kept on, 15 seconds, how long should the soap be kept on. Currently it is I think 8 seconds, so apparently I want to make this like 3 seconds. So let me change this in the code. And then how long does it wait after it's, dispensed water or soap. So here we can change this and make it, 500, half a second, you know. Yep. So after it dispenses the soap, it's going to wait half a second and then move to the next state. And then this is just the value for setup delay when I'm setting things up. And then I specify the beep delay, how long the beeping should, the default beep delay. And then these are just variables to hold the sensor value for water and soap. All right, let's walk through this. And sorry if you're having some laggy internet. For some reason, MTN is been messing up lately. So I see I'm losing um, not losing frames, but the quality is dropping. So in the setup code, this is what we're doing. Obviously, we are opening our serial money. We are beginning our serial processing. We're just writing initialization in there. And as always in Arduino, when you're setting up, I need to set the pin mode for all the sensors and all that I'm using. So I'm telling Arduino that my water sensor is an input, my soap sensor is an input, and then my water pump is an output, my soap pump is an output, and then the buzzer is an output because you send like signals out to them. Then by default, I'm turning the pumps all off so they don't kick off immediately and start, jumping off. So I'm applying a low voltage or dropping the voltage, and then the pumps are down. And then I'm setting the RGB pins, also telling them that these are all outputs. So red pin is an output, green pin is an output, and then blue pin is also an output. And then here I am using a function I created, set color. Uh, because C++ doesn't do strings as switch cases and all that, I just use numbers. So one is for red and two is for green, and by default it's going to show green when the system is available to use. And that's it. We wait for about some milliseconds, and then we tell you that we are ready to go. Then this is our method to beep. So when you realize that when it started, you could hear beep and then beep beep when it's done. This is just a simple function that does a beep. So I don't have to rewrite this whole code over and over again anytime I need to beep. And then this is the function for setting the color. So when you pass in one, it turns the red low, and that's how it is. The RGB LED I'm using is a common anode, which means I have to connect. They share a common, positive voltage. So I have to sending it low actually turns it on. If you were having a cathode, a common cathode, then setting it high will turn it on. So just be aware of the type of RGB LED you have. So this is a simple function to do that. Then in the loop, all I do is that continuously I'm trying to read the sensor value for water and soap. Now, if I get a water sensor value, then what am I doing? I beep once. I open the tab. I set the color to what? Red, because I'm using the pump. And then I just turn the pump on by sending a high signal to the pump. And the pump is going to run for keep water open for the duration I've specified. And here, as you can see, this is for 15 seconds. So it's going to keep the tap open for 15 seconds. Now, according to WHO, they say we should wash our hands for like 20 seconds running. So I can configure this and make it 20 seconds. And then once I'm done, I close the tap, I set the color back to green, and then I close the pump. So this is the same thing. The same thing is repeated for when a soap sensor value is found. Quite, simple. Again, I'm going to make this code base available for you to check out on my GitHub repo. So that's it for the code. Okay, so now, what have I learned so far in the process of the build? A few things. One, first of all, let me bring this here. I shouldn't have closed it. Just a sec. I think I need to bring back the code because I want to talk about some changes that I want to make to it. I want to share that. Okay, so first of all, just so you know, this eventually is going to be solar powered. I have a huge 150-watt solar panel outside there. I just need to get a battery and a charge converter and I'm done. So that even without sunlight, you can still use it. So hey, it's going to be solar powered. That's one thing you should know. Now, that is out of the way. After a few iterations on the structure, which I use PVC pipes to build, if I were to build another one, I would go for a bigger pipes, because one, those would be easy for me to pass the tubing into the pipe. That's one. And then two, it's going to give the structure more rigid and a more solid, feel. Because I use, smaller pipes, I had to reinforce the structure in different places just to keep it, a lot more steadier. So that's one thing that I'll do. And then also, I noticed that when I'm washing the hands, there's a bit of a splash coming my way. So another thing I'll probably fix on it is to extend the sink, my foil sink, is to extend it closer to me so that, and I probably use a bowl. This time I'm looking at like a plastic, one of these rubber bowls, like big containers. And a bit, one that is a bit deeper and up so that it can contain the, the washing and the splashing in internally. So that's something I'll do differently. Considering we're on lockdown, I just trying to make use of everything, things that are just around me, but then making note of making notes of the changes and the systems that I want to change. So that's the other one. Now the main problem. Let's go back to the schematics. Now, and this is something that really hit me when I eventually took the setup outside. So all this time I had been building like in my office here where I do the my streaming. So technically low light, building in low light. So I didn't really see much of sunlight interfering with my design. However, when I took the rig outside, this is what I realized. Immediately my palms they were just running. And I was like, what's happening? I thought I had some short circuit somewhere. I went into the box, I tried fixing it out. It was still the same, so I shut it down. And then I decided to test a situation out. It turns out that the IR sensor I am using reacts to sunlight because the sun also produces IR waves. And because the IR proximity sensor responds to it, it detects sunlight, it interferes with it. So this will not work in an outside or sunny situation. So that was my first gotcha. I was like, oops. So instead, I'm going to replace those IR sensors with this, with an ultrasonic sensor. These can work, in sunlight with no problem. So now on the rig, one of the modifications I'm going to do right now after the show is to replace this IR sensors with this. And that solves the challenge. Yes, it poses a little of a challenge because the IR sensor has 3 pin outs, but this has 4. So now I need to try to wire one more ground or something and share amongst my code. So that's it. And that's the first one. And then two, in as much as I'm using an Arduino now, I would want to change and then use an ESP32. Yep, I want to use an ESP32. And the reason why I want to use an ESP32 is that now this ESP32 is Bluetooth and Wi-Fi enabled. So which means that now I can run things like checking the volume of the water, checking the volume of the soap, sending a count of how many people have used it, and then do whatever analytics I want to do. Send it to Power BI, use some flow to send me an email when the liquid soap level or the water levels are dropping or whatever it is or abnormally. I can send it. So that's what I want to do. So I have two of them here. So in the final rig, I want to change that and use this. It only means I'm going to have a few soldering to do, but hey, once it solves the problem, we're good to go. So that is that's the next thing that I would do with this. Now, then with this set, the questions are, Sam, is this for sale? We want to sell it. As of now, that is just a prototype. I figured out how I'm going to do it. So potentially, I won't say yes or no, but I will communicate with you in due time. So that is what I have learned. Also, the other thing I also want to do is this. I want to make all these values here. Let's go back. Let me switch to the screen so I can show you this. I want to make all these values here configurable to the extent that I can use a mobile app, or I can use a cloud solution, whatever I have, or I can put some dashboard on the system that I can go in and say, you know what, keep the water out for this second instead of the hard-coded one. As of now, if I want to make any changes, I need to go into the box, connect a USB and do. But the ideal thing will be, that's why I want to use the ESP32, because then I can have a little web server running on it, and then I can send requests to it, and that's going to alter these variables to it with that cloud as well. So it makes it quite easy. So you can control it from a smartphone. Just go to hit that URL and say, hey, I want to use this, just dispense this amount of soap and this amount of water. That would be the next thing that I would do to it. So yeah, in terms of the code, that is it. Now, as if it's not enough, it looks like we're going to be running quite fast on the show today. So, as if that's not enough, obviously, after you use the tissue, you need to dispose it off, right? Yeah, you can't keep the tissue once you've finished cleaning your hands. So this is what I'm working on now. So I'm going to convert this bin into a smart one. A smart one that does two things. A smart one that that opens up for you to put the the paper towel, and that also tells me when it's getting full so I can pick it up and do whatever I want to do. So that's the next one I'm working on. So I can guarantee you that the build is going to continue. I'm hoping to, make the alteration to the build today, tomorrow, and then, sometime this week. All the final thing will be done for me to take it outside and then have, just my friends and neighbors and people who are around me test it out. So what else? I had wanted to share something. Yeah, that's all about the show. But then I want to show you. I want to play another video, that is showing you how I I built. So I've shown you this. I've shown you that. So I'm going to show you how I started the whole project. Yep. So that's how I started. So I started with this submersible pump, which I have here, right here. This is what I started with. So I dropped this in the water, and I just tested before I used the pump, and then um, after that I went ahead with this.
So, final build is done. Um, yeah, it took 5 days. I missed yesterday because I wanted to see my old man. Didn't come home quite early. But hey, electronics is done, all sealed in the box. I'll show you the final electronics later on. But this is the final structure. As you can see, I have some reinforcement coming here and some reinforcement here as well. And then in the middle, some reinforcement. So now, this is how it looks. As you can see from the side, yeah, sensors have been fixed. So this is blue for water, red for soap. Yeah, I know it doesn't look neat, but it's just a prototype. We can figure this out later on. So here for the paper, tissue paper or towel, I just added some sellotape and some paper wrap so that it could hold the paper tight enough that it wouldn't just be loose when you're tearing it. So I'm still figuring out the better solutions for this. Then the back, all controls have gone in. I'll open this up later on. I did a few modifications though. That is, if you can see, so I added a switch and then an LED for status. Ideally, this should go forward, but it's just for my own sake. And now, so finally, this is going to be the hose for water. So you drop this in a bucket of water, in a tank of water, whatever that is, you drop this in. And then here, this one here is a liquid soap. You drop this into a bottle of liquid soap or whatever that is. And then here, this is the power. So this is going to go to the solar panel. All the wirings have been done. And then, yeah, so now all that is left is for me to seal these things and then, yeah, test it out.
Yep, so that's what you saw today. We tested it out. Now, and also, a gotcha on the solar panel. The solar panel I have is 150 watt. It gives off um, the voltage I need. But the problem I realized was that I was connecting the solar panel directly to my power source. So it kept alternating. So it would go on beep, 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 which is because that's how it charges the battery. As of now, I don't have a battery on it yet and a charge controller. So anyone who has any spare battery, 12 volts, battery lying there, deep cycle lead base is preferred. And you don't know what to do with it, just let me know. I'll find a way to pick it up and make use of it. The idea is to make the self-sustaining, replenishing and all that. So I'm still looking into making that a reality. Now, so another question people keep asking, how do I get my hands on these things? First off, I said I'm going to make the whole project open source, so you can go have a look at it if you want to. Now, if you want to have access to it, some of the components and things that I got, you can get from Geek Store. All right. So Geek Store is your one-stop IoT hobby shop. online shop currently in Nigeria, but we're working on the Ghana store as I speak. So pretty soon we're going to announce when the Ghana store is open, and then you can get all your IoT controllers. You can get pretty much everything I used to do this build. You will get it from the Geek store. So just keep it crossed. I'll make the announcement when it's finally here. Let me actually get to the let's see. I'm trying to pull out. Let me get this for you so I can share with you so you see that where actually stuff is being worked on. So just give me a sec here. Let me pull this out. I don't know, but for some reason today internet seems to be very slow. So that's how I built it. If you have any questions pertaining to the build, pertaining to all that, let me know. So yeah, so this is where is that? It's taking quite some time. Well, I don't know, but it's amazing that the stream still looks good even with the current situation. So this is Geek Store. This is the Nigerian store, as I mentioned. The Ghana store is actually coming. So on the Geek Store, you're going to find, all the IoT stuff, everything that I've been using right now, particle mesh, all of it, all the boards, Arduino, Groove Pi, the sensors, everything that I used in my build, you get in the Geek Store. So for all my Nigerian fans and followers, check out the Geek Store right now. Geekstore.com.ng is the place to go for all your IoT supplies. Very soon we're going to have the geekstore.com.gh, the Ghana one coming up, so you can also purchase all your IoT boards and for your hobby stuff if you are in Ghana. So that is what I have for you. It's quite short, but I promise you that so next steps. First of all, I'm going to make it cloud enabled, definitely on Azure IoT. So I'm going to connect data to Power BI so that it can tell me, the usage of the system. That is one. And then two, for the bin, is going to tell me when it's so for me to dispose of it. I'm thinking of actually gamifying the whole system and adding some very tweaks to it. Some of it I won't disclose. When I'm done, I'll share that. But hey, if this was useful and you want to know more about how I built it and how I, did it, feel free to connect with me. Feel free to, ask any questions and I'll be very glad to, answer it. And then also, we'll be coming up with an IoT bootcamp. So keep watching the space. Once this whole thing goes down, and we beat the virus, I know we're going to beat it. We're going to have a series of IoT bootcamps that would allow you to learn and do this. And please, if you haven't subscribed to the channel, please, please, please subscribe. Subscribe to the channel so that you'll be notified when I release, so that you'll be notified when I get new stuff going. And then if there's something you want to build, or if there's something you're thinking about, or you think that I should build on the show, just send me a, WhatsApp, Twitter message, anything, and then I'll respond to it. Now, before I leave, let me leave you with what has been trending today. Okay, so moment of truth, come to test it. There you have it. So, thank you very much for watching. Quite, a brief and short one on our IoT show today because I am trying to get stuff done. And then, hey, again, if you have any questions about this build that you've just seen, or if you have any questions or any concerns, hey, make sure to connect with me on social media and I'll do well to, address that. Until I come your way next week with another edition of IoT Tuesday. This has been Samuel Adrian. Stick and stay. Follow me on social media and see all the craziness that's happening. I'm going to be making some updates as well. So stick and stay with me. Be safe, stay at home, and do something fun. and let's make a world a better place for all of us. Till then, I'm out.